I'm going to start off this presentation with a quick narrative that I generated for a lightning talk I provided shortly after Hurricane Sandy, when people had become especially interested in my field for obvious reasons. At 9:30 in the morning on October 29, 2012, the storm surge of Hurricane Sandy hit New York Harbor almost exactly at high tide. A few hours later, as seen in these pictures, it was high tide in Boston Harbor. 6 hours after that, the full force of Sandy's storm surge hit Boston, but it arrived at low tide. No one even noticed. However, if Sandy's full storm surge had hit Boston at high tide, the flooding in Boston would have been similar to the flooding in New York, flooding that caused damage that I would not have wished upon even the most diehard Yankees fan. We'll start this next segment by talking about misconceptions regarding climate change. First, let's talk about carbon dioxide, more generally referred to as carbon. It's really carbon dioxide concentrations we're talking about here, not carbon. The first misconception that we'll discuss suggests that carbon dioxide concentrations have always varied and that the current trend of increasing concentrations is just part of a naturally varying cycle. So there's no reason to be alarmed about carbon dioxide levels, or is there? What's true is that carbon dioxide concentrations have always varied, as we can see from this graph, which is based on ice core data. For the past almost 1 million years, carbon dioxide concentrations in the atmosphere have never exceeded a threshold of 300 parts per million. However, the current trend of increasing concentrations is not part of a very naturally varying cycle. As you can see here, the 2008 observed level of carbon dioxide in parts per million is right around 350. You may have heard of the environmental organization called 350.org. Their name is based on that number. When you get further out into the future, the modeled predictions of carbon dioxide levels in the atmosphere suggests that the level will ramp way up. This chart shows two possible scenarios for the future: a high emissions scenario and a low emissions scenario. The high emissions scenario assumes what I like to call business as usual. This high emissions scenario generally assumes that we do not change our patterns or our lifestyles regarding emissions of carbon dioxide. Business as usual. The low emissions scenario effectively assumes a radical change towards a greener lifestyle: solar energy, wind generator, electric cars, etc. But that is just not happening today. On a global scale, we continue to do business as usual. So the high number is a more likely projection of what we can expect by the end of the century. As of May 2013, we have a current update on carbon dioxide levels, and you can see at that point we had hit the 400 parts per million level. The thing that's interesting about this chart as compared to the prior chart is that the right side of the chart provides a zoom in on the past several decades to show that the current acceleration of this trend beyond the 300 parts per million threshold. Another misconception suggests that carbon dioxide can't be the problem because it's just part of our natural cycle. We exhale carbon dioxide, plants absorb carbon dioxide. The issue here is one of balance on a planetary scale. As you can see on this chart, there are all sorts of processes by which carbon dioxide is absorbed or emitted into the atmosphere, and it indeed is a natural cycle. What's different now is our impact on that natural cycle. Most importantly, since the beginning of the industrial era, we're talking fossil fuel, carbon stored inside the planet for many eons, and we're bringing it up to the surface, and then we're burning it. We've upset the balance. A third misconception is that there's no evidence that climate change is real, and there are a lot of self-proclaimed experts, many of them who are not scientists themselves, promoting this misconception. So, do we really have any evidence that climate change is real? Here are 3 scientific observations, and there are many others. Ice caps and glaciers are melting. Sea level rise appears to be accelerating. And we're experiencing extreme weather events of increasing intensity. These observations are consistent with what we understand about climate change. The last misconception we'll discuss today suggests that humans are too small to alter natural systems at a global scale. Let's look at the data that contradicts that misconception. humankind has converted 1/4 of the Earth's surface to agricultural. Greater than 50% of the forests have been converted. Approximately 50% of grasslands have been converted, and most of this has occurred since 1950. Since 1969, that amount of water stored behind dams has quadrupled. What we're in now is generally being called the Anthropocene, even though there's no consensus yet on this term. The Anthropocene is generally defined as the geologic era during which humans have begun impacting the planet. So moving beyond misconceptions into science, I'm now going to cover some of the findings from the United Nations organization called the Intergovernmental Panel on Climate Change, a group with many, many scientists. The IPCC 2007 Summary for Policymakers reported that it was unequivocal that the Earth's climate is warming, and very likely that human emissions are chiefly responsible. Looking at this slide, we see a multicolored bar across the bottom. The bar provides a nice translation the IPCC has developed to provide a bridge between science and policy language. For example, the IPCC equates the policy term very likely with the scientific confidence level of 90%. In September 2013, the IPCC released the latest summary report for policymakers. They still find that it is unequivocal that the Earth's climate is warming. But in this year's report, the IPCC states that it is extremely likely that human influence has been the major cause of unequivocal global warming. Using the IPCC translation between policy language and scientific language, extremely likely equates to a 95% degree of certainty. Let's look at some of the critical talking points from the 2013 IPCC report that relate to sea level rise. The report states there is high confidence that ocean warming dominates the increase in energy being stored in the climate system. Just like a lake or any large body of water, the ocean is a heat sink and has absorbed and is now storing a lot of heat. So what does this mean? Well, imagine that we decided today to go into what I call caveman mode. We turn off all the lights, we live in a shack, however you want to define it. Just stop using electricity and petroleum fuels. Stop emitting carbon dioxide. It's not realistic, hence the term caveman mode. Yet even if we did all that, we would still experience the effects of climate change, including sea level rise, among other effects, because the ocean has stored all that heat and it's going to take a long time to release that extra heat. Other points made by the IPCC include their conclusions that the global ocean will continue to warm during the 21st century, and heat will penetrate to the deepest ocean and affect ocean circulation. They further conclude that global mean sea level will continue to rise during the 21st century, and the rate of sea level rise will continue to increase. It's not just a straight line anymore. Sea level rise is accelerating. And here are two very important points. Most aspects of climate change will persist for many centuries, even if the emissions are stopped. That's referring to the caveman mode I mentioned earlier. And this represents a substantial multi-century climate change commitment. We're in this now. We need to be able to recognize misconceptions about climate change for what they are, misconceptions. And we can do this by learning more about the science about climate change that's been well articulated by research organizations such as the United Nations Intergovernmental Panel on Climate Change.